Thanks for having me, and thanks for Lars for that unique introduction. I think that's probably the best way to describe it. We are here to talk about how we're building serverless JavaScript applications easier on Azure. As Lars mentioned, my name is Aaron Powell, or Aaron. I done messed up. If anyone watched Key and Peele, you'll get that reference. I do work for Microsoft, unsurprisingly, giving a talk about Azure. I work for Microsoft. I'm actually in the .NET advocacy team, and I'm here talking about JavaScript. And it was kind of a fun conversation with my boss, because I submitted this talk and got accepted, and I was in the JavaScript advocacy team at Microsoft. And then I got told that I was going to be moving to the .NET team, and I had to say to my boss, so, I have this event coming up. And they were like, it's okay, mention .NET at least once. So I've done it like 3 times now, so we're done. Yeah? If you want to find me on social media, I apologize because it's social media, but I am there on various locations, and if you don't get a chance to talk to me at the Microsoft booth afterwards and ask me any questions, feel free to reach out. I'm always happy to answer as best I can. But that's enough about me. We're here to talk about serverless on Azure, and in particular, I'm talking about Azure Functions. So Azure Functions, and I just want to make sure that we're all on the same page of what Azure Functions is, because I know there's a lot of people that are not overly familiar with Azure that are in this audience today, and judging by the sessions, a lot of AWS content here, so I want to make sure that we're all on the same playing field. So Functions is our approach to doing like code-based serverless programming. So it's event-driven. So an event could be like a HTTP request that's come in. It could be a message being put into a storage queue. It could be a database record being written to Cosmos or SQL. It could be a variety of different other things that are happening within inside of Azure. And that's something that you're going to be listening for. You're going to wait for that event to happen. And then you can combine that with other things within inside of Azure. You can get data out of a storage account. You can read data out of a SQL database. Combine that together as a set of inputs to the function that you're going to be executing, so your little serverless script that's being executed. That'll get processed and then send out some outputs to whoever is consuming the output of that, or none if it's just like a batch processing job that doesn't need to write anything out there. It just processes data and it just vanishes, because that doesn't make a lot of sense. Data's got to go somewhere, right? Anyway, we've got all the tooling you'd kind of expect from this, so local dev, debugging, and all that sort of stuff. But it was actually originally built for just like running entirely within inside of the cloud. And to understand a bit about what we're doing to make it better to build JavaScript applications with Azure Functions, I want to talk a bit about how Azure Functions works from kind of a technical standpoint. So as I mentioned, there's a trigger that's going to happen, so the event that's going to start off and make your function execute. So let's use a HTTP trigger as an example here. So this is a request that's coming into the HTTP endpoint, and that's going to then start up the Azure Functions host process. Now, this is a .NET application, and this is what is kind of the guts of Azure Functions. So this is then going to get all the data from any additional bindings that you've got, so your database or storage accounts, queues, etc. Like that's going to get brought in to the function host as an input payload. But this is a .NET process, and we're talking about how we're making it better for JavaScript developers. And, well, I mean, they're not the same thing. JavaScript and .NET are not really the same thing. I mean, TypeScript kind of bridges that gap, but still, it's not the same thing. So how does that work? Like, you can't run JavaScript inside of a .NET runtime, really. But what we do is we bring in a worker process. So this worker process is written in the runtime that you're targeting. JavaScript, Python. It could be in .NET if you're doing isolated .NET worker processes rather than in-memory ones, which are actually running inside of the function host. Or it could be a custom one that you've built for yourself because you want to build something in Go or Rust because it's modern and cool, and that's the way we should be doing programming these days, is with those languages that I have never touched and don't understand. But this worker process is running separately. So we send a gRPC message with the request payload across to it. And then finally, your bit of code is going to execute. The script that you wrote is going to do something with that inbound payload. It's then going to generate a response payload back to our function host, which is then going to send it to whatever the target output is. So that's the basic way that it works. We have these 2 separate processes, our worker process and the function host. You can learn more about that if you are interested in kind of like that kind of in-depth stuff on the Azure Function Host wiki, so github.com/Azure/Azure Function Host, or that QR code is also a link to that page as well. And that's also where you can learn about if you want to build custom handlers, so something that's running a language that we don't natively support for Azure Functions. So that's all good. It works. It's been around for a while. Like, we actually launched Azure Functions in 2016, and JavaScript support was one of the first additional languages that came in 2017. So What's the problem? Like, we've had this quite a while. Like, it's fairly mature. There's a lot of applications built on it. It runs at serverless scale and all that kind of thing. But, well, it doesn't feel over JavaScripty. Now, like I said, this was built in 2017. That's when we first released JavaScript support. And if we think about the way that we were building JavaScript applications then versus the way we do them now, it's quite different. And as a result of that, we see these nuances bleed into the way Azure Functions works. It's very reliant on a specific folder structure on disk. So you have to have files called a function.json file, which is going to describe how your function is working, and then you have your script file that's actually going to be executed. And you have to have as many of these folders as you want. It's all a fairly flat folder system as well. You can't have folders within inside of folders. It will also not look into particular folders, like your node modules. You probably don't want to look in there. You don't need to parse like 30,000 folders to work out if there are functions in them, because you've built a Hello World application in this node and you've brought in 30,000 modules anyway. So we're trying to optimize it, but that's not kind of the way we think about building applications. Like, at the end of the day, it doesn't really rely on anything out of your package.json file. Did you know there was a time we built JavaScript applications and we didn't use a package.json file? Or like Babel or a compiler? Like, it blows my mind to think of that. But that's kind of where we were sort of 6 odd years ago when Azure Functions was first designed. So, because we don't rely on that, we're not really leaning into the ecosystem as well as today when we're building a JavaScript application. And because it's not so much of an application in serverless, it's a set of script files in a serverless architecture, it's difficult to do things we would expect in an application. It's difficult to create middleware, for example. So you want to process something before the function is actually executed. Well, because these script files don't really know about each other, you have to create like a higher order function, or you copy and paste code around, and you end up with like magic strings that you've got to make sure you're getting correct in each location. So it's, again, it's feeling very scripty, which makes sense because that's how it initially started, not very application-y, which is where we are today. It's also difficult to create like a third-party library that brings in additional Azure functions. So you've got some common functionality that you want to use across multiple applications within inside of your organization. Well, you kind of have to copy and paste that code around, or create helper functions that you can import out of a node module to then add to your function stack, because it's expecting a folder structure, which is not really the kind of way it works. So let's have a look at how that appears from like an actual code standpoint. So I've got an application here. It is a to-do application because this is a conference talk and it has to have a to-do application as the way that we build our code. And I'm going to just start this up with npm start. And this is ready with Azure Functions, unsurprisingly, given it's an Azure Functions talk. So at the moment, it's starting up our local emulator, and then it's gone and discovered all the various functions. And we'll notice that the functions that it's got here, whoops, wrong button. The functions that we've got here, things like delete to-do item, get to-do item, et cetera, matches the folder structure we have here. Delete to-do, get to-do, et cetera. So that's because it's parsed these folders, and that's how it's got the names of the functions, and it's worked out stuff by looking into those individual folders. It's ignored disk because it doesn't have a function JSON file. It's ignored the VS Code and the node modules because they don't have function JSON files, or they've been explicitly ignored by the runtime. Okay, so let's just prove that this is an application that does actually work, and we'll come through and let's go and execute just a health check. Okay, cool, it's up and running, excellent. And then we'll come to, say, get a list of to-dos from our database. There's currently nothing in our database. I have it connected to a Cosmos backend here. If we refresh, no documents, as we expect. We can create a post, we can send a new one up. So there we go, we should have a new one in there. And if we refresh our document collection, there we go, BZFI is in there. I can then come down and execute, like I can get one by its ID, so kind of like very REST-esque, this application, or this API stack that I've built. We can update an individual to-do, and then lastly, just get back, verify that we did persist that data to the database, and let's just delete it to clean up at the end of the day. Cool. So let's have a look at how a couple of those functions are implemented. Whoops. Let's not change that file, because I'll need it later. And we are going to have a look at, let's say, the get item. So we've got these two files here, function.json and index.ts. Because I've written this in TypeScript, because I'm a TypeScript person rather than a vanilla JavaScript person. I like type safety. What we've got here, first up, is we've defined a binding. The first of the bindings there is the HTTP trigger binding. So this is the one that's going to be starting this serverless function. So it's the event that we're listening for, and we can note that by the fact that it's called HTTP trigger. It's an input the direction is input, so it's an input binding as opposed to an output binding, which is our HTTP one at the bottom. So we're sending a HTTP response. We're defining the local variable that it's going to be known as, .rec or REQ. It's listening on HTTP GET, and it's the route that is there. And we're parameterizing this route with the squiggly brackets. And we're then bringing in that to-do item. So we're binding to our Cosmos database and bringing that data in. So I get back so I have to say, well, here's the database name, the collections, the connection string, because I want by ID, so here's the ID, it's that parameter from the thing a bit up. And you can kind of see that we've got a lot of magic strings that are happening here. Database name, items, Cosmos connection string, the ID and the partition key, they're all kind of, they're in this JSON file, and what if I need them elsewhere? When I actually execute my function, it's a basic function. We get that item passed in as the final argument to our JavaScript function here. But how do I know that it was the final argument? How do I know it's called to-do item? Well, I jump back to the other file and it's there, so I know I can understand the order. And if I add more bindings, then the order could change because I put them in a different, and things can get a little bit disconnected because I've got these two files that I'm jumping back and forth between. But okay, so that's how we can do one that brings in something that's it's just using all kind of native bindings. What if we want to do something that can't be done natively, like a delete item? There's no way that we can do a delete as an output of an Azure function, so we have to write that ourselves. So this one's really simple. It's just the binding of a HTTP trigger and a HTTP out binding. But then in the function, I need to make sure that I'm connecting to the Cosmos database or the Cosmos collection. So I need to make sure that the connection string is correct. So that's the name of it on process.env. So we've got to make sure that then that's obviously the name that I've got here in this JSON file and the to-do items. Again, magic strings are starting to creep in. Things are, we're just assuming that we got things correct. We're not doing a whole lot of code sharing. And if I need to use a Cosmos client elsewhere, the patch operator, so the put operation, that also needs to establish a connection because it's doing a replace rather than a create. And that's not available via bindings. So we've got to copy and paste this code. It'd be really nice if this could be injected, middleware could be doing this for us. And as you can see, this is very script-centric. And it makes a lot of sense given its heritage, and the way that it works can work for a lot of styles of applications, particularly a serverless architecture. But when we're thinking about it as an application, it starts to feel a little bit clunky and a little bit less JavaScripty. So, we've been making some improvements. And by we, I mean a team of us at Microsoft. So while I was in the JavaScript advocacy team, I was working with the engineering and the PM team for Azure Functions that owns JavaScript, and look at what can we do to make this feel more natural, more like an application that we'd be building rather than a series of scripts. So we started off with some low-hanging fruit. The first was, well, let's improve the TypeScript support. There's a lot of unknown and a lot of any's. And that's because, well, we've got this JSON file that lives somewhere, or it's very difficult to do type annotations, and we don't even give you the plumbing to give your own type annotations as easily as it could possibly be, and the way that you might want to do it inside of an application. So we're doing a bunch of work to improve that. So if you are using TypeScript, or you're using VS Code where you get and just playing on JavaScript and got the TypeScript runtime sort of running in the background, you get IntelliSense, things like that, just to make it feel a bit easier to build a complex application. Starting to leverage the actual package.json file. When Functions was first created, we only had CommonJS as the module system in JavaScript. But since Node 16.9, I think it is, ECMAScript modules, or ESM, are natively turned on by default, so you could opt into that. If you want to use JavaScript modules instead of using CommonJS, well, you can do that. And we can now respect what the package.json is saying, because your package.json is the way that you would think about it from an application standpoint. And we've added lifecycle hooks. So you could do the concept of middleware before when the host process starts, before a function is executed, after it's executed, when the function is being shut down. You can create things around that, inject data. You could potentially even do validation of data or the inbound request and change the way the function executes based off of the result of validation. But the really big thing that we've been doing is we've been working on a new programming approach for building Azure Functions with JavaScript. You can read all about it on the GitHub repo for this, so github.com/Azure/Azure Functions Node.js Worker, issue 480. And this is something that we worked with the engineering and the PM team on to kind of bounce back a bunch of ideas. What does it look like to build a JavaScript application from just a language standpoint and a programming standpoint? Not necessarily architecturally, but just improving the language approach. Can we use things like decorators or classes, maybe more of a fluent API to bring it to an application standpoint, like you would do with, say, Express or Fastify or those sorts of patterns? And this is one of the ideas that we came up with. This is actually a proposal that I put forward using kind of this app object, very much inspired by your Expresses, etc. And we take that Azure function that we were exporting previously from a script file and bring it in and registering that explicitly. And then everything that was in the function.json file, bringing that in as JavaScript objects. And because of this, we know what the structure is of the bindings, and we can then infer more type information for you from that. Another one of our team proposed using decorators. They're very heavily involved in the Angular ecosystem, and this is a common pattern inside of Angular. Using decorators that kind of mark up the function the way that we've already got. So you could just export it as a normal function from a script file, but you mark it up with a HTTP trigger. This is going to have a get and auth level. What are the other bindings that you might have? A potential drawback of this is that the decorators aren't actually native to JavaScript yet. So you need a pre-compiler for that, TypeScript or other. They're proposed, but they're not a part of the language yet. Maybe we go down the route of using classes particularly for your bindings, your inputs and your outputs. Now we can really structurally infer type safety because we have a class that defines types. We don't have a JavaScript object we have to infer type based off of the properties that you've got in there. We know what it is, and we can give you richer types as they go into the function that's being executed. Ultimately, this is the design that we settled on. It's kind of fairly similar to that first one we showed before, but we have some higher order functions. App.get is going to be a HTTP function trigger because that just makes sense. And because we know what it is, we can then infer, the first argument of that function is going to be a HTTP request object. We know the response should be a HTTP response object. We can use the built-in types in the Node.js type system, or the TypeScript information for Node.js to expose those. We don't have to have these custom type objects that represent things. So you can just program it the way that you would be doing things with fetch or and stuff like that natively with inside of a Node application. It just so happens that you're then hosting that with inside of an Azure Functions. So let's have a look at how that would look like in a demo application. So we've got the same demo application here. Let's stop the old one, and we'll come into the new JavaScript, and we'll do npm start. And while that's firing up, let's go to index.ts. So this is that exact same set of functions that was split across multiple files, now mostly with inside of one file. If we have a look at how this appears with inside of the folder structure, we'll see that it looks a lot more application-y. We have our, so here's our top level folder. We have a source directory, and inside of that, we've got an application set of files. We have a package JSON and all those sorts of things you would expect from a Node application, rather than a series of separate scripts with inside of this. And that's started up now, so it's discovered the functions that we've registered with the names that I've provided them. And that's things like get to-dos, get an individual to-do, etc., etc. Now, I am using a slightly different pattern because I need to provide extra bindings. This isn't just input and output HTTP bindings. I'm also adding things like the Cosmos input binding. So I've defined that in a separate file, so that this is then a consistent binding I can use in multiple locations. I provide the base bit of Cosmos connection information, the to-do list, so the name of the database, the container, the connection string, stuff like that. And then I create input and output bindings off that. And then where needed, I can add additional information, such as the name of that to be exposed with inside of the function invocation. In this first case, it's going to be performing a SQL query against that to get the data back. So let's go to our operations. Oops, operations again. Come back up to the top. And if we go and run that, it's working exactly as we expected it to be working. It's working the same way as the previous one does. So we can get back, well, no items because we deleted the last item out of the database. we can create a new item. Actually, let's go back into the index.ts file, and let's stick a breakpoint on this get item by ID, and then I can pop down here, run that, and we realize that we have like a really zoomed in screen, so we have to move everything around. But yeah, so now we've got in, we can hit it, like it's very easy to set a breakpoint. We can see that we've got like a body that's come in. Obviously there's no body because this is a GET request, or no body that we're listening to, but that's something that we can then read as a stream and work with it as more stream data than just like, just blob objects that we'd be pulling in. We have a params collection, which is the segments of the URL that we're unpacking and things like that. Let's run that through to execution. Excellent. Now, another thing that we were wanting to solve, or wanting to solve better, was the way that we were working with like that delete, where we had to establish the Cosmos DB connection. So let's come down here, and now instead of having to connect to the database directly, we have this extra input where I can get a Cosmos connection back out. And that's because I've got our hooks, and inside of here, I've registered a pre-invocation hook. And here we're using the Cosmos settings, same as what's being used by all those bindings for connection string, collection name, etc., to make it so that we don't have less of those magic strings around. And then I'm establishing a Cosmos connection, adding it to extra inputs that are available for that function. Kind of pseudo dependency injection here, well, at least dependency injection as well as we could do in JavaScript. And then if we were to run that delete operation, there we go. It comes in here. We can then execute through. Actually, let's put a breakpoint inside of delete as well. And now we have our extra inputs, and then I can unpack that as an object that has like a hash bag internally where it's tracking all of that sort of stuff. And I can step over, and we have our Cosmos container. So I can get to that. And I've only had to establish that connection once. I haven't had to copy and paste code around because it is now being treated more as middleware because I built an application rather than as something that's within inside of this one script. Now, I'm almost out of time, or at least I hope I'm almost out of time because I'm almost out of slides. So just to wrap up, if you want to learn a bit more about this new approach that we're taking, you can check out the working doc on the GitHub repo, which is at aka.ms/azfuncnodv4. It's a mouthful to say on stage, I can guarantee you of that. But something to be aware of is this isn't released yet. So this is something you can play around with your local environment, you can do local testing with and stuff like that, but it doesn't work in Azure, or it's not guaranteed to work in Azure, it's not supported in Azure yet, because we're still iterating through it. In fact, writing this talk, I submitted a bunch of feedback about the way that we were using the hooks to be more middleware-esque, because I feel that there's some options we can do to improve that a bunch. So I submitted like half a dozen feedback requests to the engineering team on that, and they're like, thanks, I wanted more work. But prototype around this, see how it works. Like I said, try it out for local development. Right? Does it make building an application with serverless easier than a set of disconnected scripts? And most importantly, provide feedback to us. If you are building with this, if you are trying it out, let us know how it works. Like, is this model actually working the way that we envisaged it would work? We've done some customer studies with it. Some of the early prototype ideas that we had around the programming model, we tested those with customers and ran them through scenarios to get their feedback on them. But the more feedback, the more we can make it correct for as many people that are wanting to use this. Finally, build awesome stuff. That's I think my main takeaway from this is that there's so much cool thing that's happening in serverless at the moment, and just build awesome stuff with it. Thanks for having me. I see Lars is in the wings, so I'm probably going to have to get off stage shortly, and Sarah's going to get upset if I eat into her time. But thanks for letting me talk a bit about how we're trying to make building serverless JavaScript applications with Azure easier. If you want to contact me, you'll find me online there, or you'll find me up at the Microsoft booth for the rest of the day. Probably just playing Forza, let's be honest. If no one's there playing it, it's going to be me. But thank you.